So I'm from ServiceNow, from the Appsy team. I'm not sure if any of you have ever heard of it. Appsy used to be a startup based here in Tel Aviv. We offer mobile analytics, and today as part of ServiceNow, we offer analytics solution both for internal needs and for customers across web, mobile, and chatbots. And I'm happy to present you our ClickHouse solution for analytics. Now it doesn't work. Okay, so I will talk about the motivation of replacing our previous model before ClickHouse, how this model looks like, the requirements that we wanted to have in our new solution, how we achieved real-time segmentation using ClickHouse and actually dropped the previous model, and the future work that we are planning across ClickHouse. So let's start with the question, why would we replace something that works? The motivation to replace an existing reliable model is actually from the product growth. We wanted to give the customers the ability to real-time segment their data and dynamically slicing and dicing everything as much as they want in live, and also give them the ability to real-time funnels and cohorts on their data. These capabilities will give actually also for us and also for them the ability to understand the user behavior better. So let's take a look on the previous model. Appsy stored pre-aggregated data to allow an interactive dashboard experience. Each pre-aggregated table was segmented by a fixed number of dimensions: the application, the app version, and the platform. Platform can be chat, mobile, or a web. Appsy holds about 30 different tables, and some of them having some more dimensions. I'll give you an example before that. We also give the customers the ability to send us a custom properties key and value dictionary that afterwards we want to show them the counters grouped by those keys and values. I'm not sure if you can see, it's really small, but for this event of open dynamic segment form, we have a group for each counter. We have a counter for each group of the key and value. So this pie chart actually shows each value from each key. So how it looks like in the table previously ClickHouse. This is a process message that we got from the device, and this is the app segments table. We get the segment ID using the app ID, the platform, and the app version, and this is the event occurrence system. The counter is grouped by the event name, the day, and the segment ID. So actually this will become 54 count. For the custom event properties, we also use the key and value along with the event name, day, and segment ID for grouping the count. While this is great for quick value breakdown, dimension limitation leads to a lot of loss of analytical context. For example, we can't ask how many search started with the search term research RSA token and a click position of 3. So let's have a look on the pipeline that we had. I chose some mobile device, it can be anything, but this mobile device creates an upload metadata request, sends it to the API through the load balancer. The API takes it, puts it in our Redis-based queue, creates an upload result, return it to the device. The processor takes this message, updates the session entity inside the MongoDB, update the user entity, calculate each and every report inside MongoDB, update it, and then we perform an indexing inside Elasticsearch. If we go back to the motivation, these are the two lines that we want to change. So let's talk about the requirements that we wanted to replace. The basic non-functional requirements are scalability. We wanted the product to be horizontal scale easily. We wanted a native sharding and replication support. It has to be write optimized, and a preference to a product that is easy to use and operate. Regarding maturity and licensing, it has to be a rich documentation, has to have a big community. We use Python, so we prefer something that has a proper Python driver, and it has to be fully open source and have commercial support availability. On the functional side, we wanted to support all Apps's existing queries, such as unique counts across sessions, users, cohorts, funnels, etc. And everything has to be in a subsequent manner on the same hardware. So far we have everything, so let's add some more requirements. We want to give the customers to use their own segments, to create their own segments and to slice and dice the data as much as they want. And a bonus, since our users are mutable, means that they have their own properties and they can be changed in any second. We want to be able to do some joins between the data points, which are immutable, and the users which are mutable. For example, how many searches has been done by users, by VIP users? So let's talk about the solution, ClickHouse, and how we did it. If we go back to the pipeline, these are the two lines that we want to change. So let's add ClickHouse. Now instead of calculating each and every report, the processor breaks the metadata into a set of data points, insert everything into ClickHouse. Let's take a look on the insertion. Our existing pipeline doesn't have any Kafka in it or any other batching system. So currently, we chose to use the ClickHouse async insert queue, which is actually amazing. So let's take a look how it looks like. The processor takes the message, breaks it into a set of data points, push it into ClickHouse. ClickHouse takes it, put it inside its own async insert queue. Let's have another message. And after some time, or after, if it's big enough, ClickHouse takes this bulk and batch insert it into the table. Let's have a look on the deployment. So we have two data centers. One of them is active, while the other one is inactive. Each data center has 3 racks. In each rack, we have a zookeeper. In 2 of the racks, we have a ClickHouse node per shard. The other rack has only a zookeeper for quorum only. 3 of the zookeepers in the active side are participants, while the other one are observers. This setup will allow us to keep operate in case of data center plus rack failure. On the benchmark side, we use two servers, 16 CPUs each, and 32 gigabytes of RAM. We ingested 430 million sessions, broke them into a separate set of data points, ingested everything into ClickHouse, resulting in 2.1 billion data points, tested 6 different models across 7 queries. We tested simple counts such in row 1, 2, and 3. We tested a unique count such in row 4.
unique counts with custom properties, such in row 5 and 6, and unique counts across 2 different rows, such in row 7. So it's easy to see that mapping and ordinals wins, but mapping means that we need each key of the dictionary to put in the same column always. Ordinals is actually the process of transforming strings into integers, means that we need to save this hashing system somewhere, and in both cases we need to keep this data forever, which is far from easy to implement. Therefore, currently we choose the map type. The map type gives us the ability to save any arbitrary number of properties. We use the primary key of the app ID, start of the day of the event name, and the user ID. It's ready for ordinals migration in the future, and of course it's easy to use. On the future ClickHouse work, we plan to insert probably some Kafka and another batching processor between our current processor and ClickHouse, relying on the dedupe feature of ClickHouse based on bulk hash. It's something that eBay did. We also plan to insert the users into the ClickHouse to allow the joins, as I mentioned before. We plan to give the customers the real-time cohorts and funnels, and move to Kubernetes, which I think maybe Jack can help us. Thank you for listening, and please feel free to ask any questions.